As we scurry around the surface of our planet doing all the things that we think are so important, we rarely think how lucky we are to be living not only in a fairly benign and stable point in the Earth's lifetime, but also the life of our nearest star, the Sun. But as we look further out into our own galaxy and to others, things are not quite so rosy. Far from it. In fact, there are some downright scary as hell monsters out there that make our problems here on Earth pale into utter insignificance. So what are the scary cosmic monsters that could wipe us out in the blink of an eye? This video is sponsored by Brilliant. Up until the last 60 years or so, we have been living in what could be considered an ignorant bliss about the space, the stars and the galaxies we saw around us. From our perspective, they seem elegant and unchanging. But as our technologies for probing the universe got better, the more we found things aren't as stable as we used to think. During the 1960s, as the Partial Nuclear Test Ban Treaty came into place between the US and the USSR, the US didn't trust the Soviets to stick to the plan and thought they might be doing secret testing. So in 1963, the US launched the Vela satellite system into a very high orbit, almost 1/3 of the way to the moon, to look for telltale gamma ray bursts from nuclear tests. In fact, it was so high, it could even detect blasts behind the moon. On the 2nd of July 1967, 2 of the Vela satellites detected a burst of gamma radiation, but it wasn't from the Soviets. In fact, it was unlike anything they'd seen before and didn't match that of the characteristic double flash of a nuclear weapon, and as such, it was seen as not warranting immediate action, but instead it was filed away for further investigation. Over time, as more Vela satellites were launched, more and more of these mysterious gamma bursts were detected. Eventually, after using the timing difference between different satellites to work out the origin of 16 bursts, it was found that they didn't originate from Earth, our solar system, or even our galaxy, but much, much farther away. What the satellites had picked up was a nuclear explosion, but something far bigger than anything we could imagine at the time, and at an extreme distance from Earth. It took many years of observing similar gamma bursts and tracking them down with new network-linked telescopes that allowed their observation often within minutes of their detection. After comparing the images and the gamma burst signatures, astronomers were able to conclude that these were most probably caused by the core collapse of the very biggest stars, even bigger than supernovas, so they gave them the name hypernovas. Their extreme distance meant that they occurred billions of years ago. In fact, one of the farthest known objects is GRB, for gamma ray burst, 090429b, a gamma burst that was detected in April of 2009 and has a distance estimate of 13.14 billion light years. Considering the latest estimate for the total age of the universe is 13.8 billion years, these would have been amongst the early massive stars and hence the equally massive explosions when they died. And this is one of the issues we have with things like supernovas. They are so big and release so much energy, it's difficult to equate them to things which we see normally, like our Sun. If we look at this image taken by the Hubble Space Telescope of supernova SN 1994D in the outer edges of the galaxy NGC 4526, some 50 million light years away, it's shining as bright as the galaxy itself, and did so for about 2 weeks. Our Sun is about 1 million times the size of the Earth and is a giant nuclear reactor converting approximately 4.26 million metric tons of hydrogen to helium per second. This process releases the equivalent of about 380 million billion watts of power every second, enough to power the world for about 650,000 years at current consumption rates. But a supernova is the explosive core collapse of a giant star, maybe 8 to 15 times the mass of the Sun. To give you some small idea of just how bright these are, here's a little thought experiment. Which do you think would be the brightest? A supernova at the distance of the Sun to the Earth, about 148 million kilometres, or a hydrogen bomb 1 millimetre from your eye? Now, if you said the supernova, you're correct, and it would be about 1 billion times brighter than the hydrogen bomb. But the gamma ray bursts that the Vela satellites detected were about 10 times brighter again than a typical supernova. The stars that go on to create hypernovas are also astronomical in size and mass. Now, the most massive star yet found is R136A1, which has about 300 times the mass of the Sun, but is only about 30 times its physical size. It's also the most luminous star known, at around about 8.7 million times the luminosity of the Sun, radiating more energy in 4 seconds than the Sun does in an entire year. If it were at the same distance as our nearest star, Proxima Centauri, 4.2 light years away, it would be as bright as the full moon. However, it's thought the very earliest population 3 stars that formed about 200 million years after the Big Bang and were made from just hydrogen and helium could have been over 1,000 times the mass of the Sun. But it's also thought that because they were so massive, when they collapsed, the gravitational forces were so strong that they wouldn't have exploded in a supernova or a hypernova, but just collapsed completely and became black holes. From what we know now, the heavier elements which were created in the first supernovas and that ultimately makes up us limits the size that stars can grow to, and there are none of these monster-sized stars around now. The largest star yet found is Joshuacw, a hypergiant with a radius of 1,700 times that of the Sun. If that were to be placed where our Sun is in the solar system, its surface, as we would define it, would be just beyond the orbit of Jupiter. But for all its size, it's quite a lightweight and comes in at only around 30 solar masses. But gamma ray bursts aren't just created by exploding stars. They can also be created by what's left over after the supernova explosions. Far from just exploding and scattering all the material out into space, the gravitational collapse of a supernova is so great that the electrons and protons of the remaining iron core of the star are fused together to become neutrons and are so densely packed that it shrinks to the size of about 20 kilometers in diameter. But it still has the mass of our Sun. A matchbox-sized piece of it would weigh about 3 billion tons, and these are called neutron stars. If the star prior to its collapse had a very strong magnetic field, and it collapses in just the right way, then the spin and the temperature is also converted into a magnetic field, adding to the already extremely powerful one that a neutron star has, and it becomes one of the most powerful magnetic objects in the universe, a magnetar. Now, large magnets are normally measured in Teslas, with the Earth's magnetic field being a lowly 30 to 60 microteslas. The strongest magnet we have yet created is 45 Teslas and requires 30 megawatts of power to run and has to be cooled to just 1.8 degrees above absolute zero. The strength of the magnetic field in a magnetar is around 1 billion to 100 billion Teslas. At these magnetic field densities, strange things happen to matter. Atoms of hydrogen are stretched out into spindles 200 times narrower than their normal diameter, and the vacuum of space itself becomes polarized. This magnetic field produces huge amounts of X-ray and gamma-ray radiation, which can be radiated out in narrow jets from the neutron stars' poles, and as they also rotate very quickly, some become pulsars that act like a cosmic clock with extremely regular pulses as they rotate around the centre, and can be heard by radio telescopes. However, when a disturbance in the neutron star's crust occurs, also known as a starquake, a truly astronomical burst of gamma rays is produced, and in 1979 one of these was picked up by both Soviet and US spacecraft around the Earth and also Venus, as the strongest pulse of cosmic gamma rays ever detected swept through the solar system at the speed of light. The source was tracked down to what was believed to be a magnetar in the Large Magellanic Cloud about 165,000 light years away. Luckily for us, these gamma ray bursts are very far away and have often occurred long before our solar system formed, so they have virtually no effect on the Earth by the time they get here, because if they were close, it could be devastating, from damaging the atmosphere to irradiating half of the planet. But there aren't that many massive stars in the Milky Way, which greatly limits the chances of a GRB being close enough to cause us any real harm. So again, we have to thank the time that we are living in for allowing us to evolve to where we are now without being zapped by a nearby exploding star. Because of the huge distances involved with gamma ray bursts, neutron stars, magnetars, and the massive stars from which they come, it makes it difficult to study these directly. So a lot of what we know comes from a knowledge we have gained from our own sun, and then by applying what we have learnt to these phenomena. Now, our sponsor for this video, Brilliant, can help you do the same in your quest to understand the sun, stars, and the universe we see all around us. Brilliant is a problem-solving website that can help you develop your learning skills by breaking down complex problems into small, easily understandable parts, then putting them back together to show the overall solution build-up into an interesting conclusion. There are loads of great, totally interactive courses. They have a whole section on astronomy, from where you can discover the life cycle of stars, how they were born, how they work, and how they will end their days, sometimes as a supernova, and how this ultimately made all the heavier elements which make up you, me, the rest of the world, and indeed life elsewhere in the universe, wherever it may be. This hands-on active learning approach is great for curious people like you who want to understand the world and the universe. If you want to support Curious Droid and get unlimited access to all of Brilliant's in-depth math and science courses, head over to brilliant.org/CuriousDroid to get 20% off of their annual premium subscription.